Hi everyone, I am Soumojit Chatterjee and this is TLE Eliminators. Welcome to the post-contest discussion of today's Educational Codeforces Round. We will discuss the first four problems A to D till now. Let me just confirm whether am I audible and visible or not. Guys, quickly confirm in the chat.
Yeah, yes, you are audible, visible, sir.
Okay, thank you. So before we start, I would just want to remind you, I think most of you maybe may already know that this is the upgraded version 2 of our CP31 sheet. So basically CP31 sheet is basically a set of handpicked problems, 31 handpicked problems for each rating range from 800 to 1900. And it comes with a new interface where you can see the status of the problems you have solved. You can basically sync the CP31 sheet with your Codeforces profile. You can look at the status, and then there is a dedicated discuss section where you can discuss doubts related to the problems. You can also see your overall progress on the sheet, and then there is a leaderboard where you can compare your progress and performance on the sheet with your friends. Apart from that, 7 to 8 solutions are uploaded every week for the CP31 sheet on TLE's YouTube channel. So you can have a look and have fun whilst problem solving. Okay, so let's start with the PCD of today's contest. So the first question says 2, 0. The question asks that you are given two integers n and k. K is an odd number not less than 3, and your task is to turn n into 0. Okay. To do this, you can perform the following operation any number of times. Choose a number x from 1 to k and subtract it from n. However, if the current value of n is even, divisible by 2, then x must also be even. And if the current value of n is odd, that is not divisible by 2, then x must also be odd. Okay. So in different operations, it says that you can choose the same values of x, but you don't have to. So basically, there are no limitations on using the same value of x. Calculate the minimum number of operations required to turn n into 0. Okay, so let me explain the problem statement once. So the problem gives us two integers as input. One is n and the other is k. And it is given that k is an odd number. Okay. Now, what does the question asks? The question asks that you can perform some operations on this number n. So in this number n, you can perform some operations. What is the operation you can do on it? So suppose you have this number n, you can choose any number x. So you can choose any number x from the set 1 to k and then replace n with n minus x. So basically you subtract this value of x from n, okay? And the value of n reduces by x, where x is any number you choose from 1 to k. Okay, and you keep on doing this. So at every time when you do this, basically the value decreases. Finally, it becomes 0. And you need to find out the minimum number of operations, required to convert n to 0. So minimum number of operations required to convert n to 0. Okay, so that is the question. But then there is one important catch which is also given. It has been said that if n is even, that if n is even, then this value of x which you choose, this should also be even. Similarly, if n is odd, then the value of x which you choose should also be odd. So that means whatever be the parity of n, be it odd or even, you have to choose the same parity of x while doing these operations. And using this, you need to minimize the total number of operations required to convert n to 0. Okay, so is the problem statement clear? Guys, please confirm any doubts in the problem statement. Okay, so if it is clear, let us try to discuss the solution. Okay, so there are two cases. It has been said that k is odd. It has been said that k is odd, but we don't know what is the parity of n, right? So n can be even. So n can be even, that is one case, and n can be odd, that is the other case. Okay, so these are, just a second. Yeah, okay. So these are the two cases which we need to consider. N can be even or n can be odd. Now think about the first case. What happens when n is even? So n, for example, say n is some even integer, say 100, and k is some odd integer, right? So suppose k is 9. So what happens? How can you quickly convert n to k? Now, first of all, think about this. You have this value of n, you have this k, but since n is even and we are allowed to subtract only even integers from n, so that means that you can never utilize this 9 value for k to subtract it from n, right? Basically, basically what happens is you have the value of n which is even, right? So you have n which is even. You need to choose an even x. So you need to choose an even x, and you need to convert it into n minus x. But if the value of n is even and the number you choose x, that is also even, that means that this new number you get also remains even. So that means every time what you are doing, you are choosing an even integer. So that means it is, we can say that instead of k equal to 9, we need to always select k equal to 8, right? Why? Because this k equal to 9, this value of 9 can never be utilized. Why? Because the value of n always remains even. And it has been said in the question that you can subtract only an even number from n. So that means you can never subtract 9 from n. What is the maximum number you can subtract from n? That is 8. Okay. But now you may ask that, okay, when the question was discussed, we know that we can choose any value of x from 1 to k, right? Then why do we choose 8? Why don't we choose 4 or 6 or something smaller? So the idea is simple. You need to convert. So there is this number n, which you need to convert to 0 in the smallest number of operations, right? So if you are trying to reduce a number and convert it into 0 in smallest number of operations, it makes sense to subtract the largest possible value from n as required. So that is the reason we know that we can subtract any value of k which is less than equal to 9 from n in order to convert it to 0. What is the maximum number you can choose to subtract? That is 8. So that means when this is the case, so this was the first case which we were discussing. When n is even and k we already know is odd, that is given in the question. What do we do? The first step which we do is k minus equal to 1. Why k minus equal to 1? Because I know that k is odd. So if k is odd, this value of k will never be utilized. So for example, if k is 9, the value of 9 will never be utilized to do the operations. The maximum number of operations you can do is k equal to 8. So that is the reason we first subtract a value of 1 from k. And now, what do we print as the answer? So what is the number of operations required to convert n to 0? So basically, so I've already subtracted 1 from k. So basically now I have this number n, and you are subtracting k from this n, right? So you keep on subtracting k from this n, and this actually takes CL of n by k operations to convert it to 0. So it takes CL of n by k operations to convert it to 0. Basically, if you look into it, that if you have some value 100, and suppose the value of k is equal to 9, then that means you can never utilize k equal to 9. You need to utilize k equal to 8. So that means you will subtract 8 from 100. And if you keep on subtracting, so every time the value of the value of this n reduces by 8, and you will see that you need exactly 100 by 8 CL of them operations to convert 100 to 0. Okay, so this case is resolved. Now what about the other case? When we have, so this is the second case which we are discussing. So here the value of n is odd and the value of k is odd. Okay. So if the value of n is odd and if the value of k is also odd, then at the first step, you can do a n minus equal to k. So you can do an n equal to n minus k. That is your first operation, right? Why you can do this? Because your n is odd, your k is also odd, so both of them are of the same parity. So in the first step, you can reduce the value of n to n minus k. But what next? From the next part, now the new value of n, that is even. Look at this. When you subtracted two odd integers, the new value of n which you get is even. So now you cannot take help of this odd value of k. So now if k equal to 9, at the first step you reduce it by 9, but now this value of 9 can never be utilized. So now it is a similar case as before. So again, what do? We do k minus equal to 1, because we know now that now this odd value of k will be underutilized. We cannot utilize the maximum value of k. So we do a k minus equal to 1. And finally, what do we print? So our answer is this new value of n and this new value of k, you take n by k, seal of them. So that is the number of operations you need to convert this new value of n into 0, and this one extra operation which you already did. So this one extra operation, which is your first operation, that is the answer. Okay. So this is basically that, okay, if the value of n which is given to me is 101 and the value of k which is given to me is 9. So what will I do? First of all, I have 101. So in the first operation, I will reduce it by 9 and let it convert to say 92. But from the next operations, I cannot reduce it by 9, right? I have to reduce it by 8 and so on. Why 8? Because now this value of n has become even. So I can use only even values of x to reduce it. Okay. So is the approach clear? Any doubts with the solution? Okay, so let me discuss the code once, and then if there are any doubts, we can come back. So here the code is simple. I take n and k as input. The value of answer is 0. And we already saw that if n is even and if the value of k is odd, so you just reduce the value of k by 1, right? So it is simple. It is a simple case. This case you ignore. I wrote it. This is a redundant case which I wrote during the contest. This is not at all required because the question itself specifies that the value of k is odd. So it will never basically come inside this if condition. So you can ignore it for this part. And this is the part when n is odd and k is odd. So if both n and k are odd, what do? You reduce the value of n by k. That is one operation. So you increase the value of answer by 1. And then you finally reduce the value of k, because now you know that this odd value of k cannot be used. Finally, you increase the answer by the seal value of n by k. Note that the seal value of n by k can be written like this: the floor value of n plus k minus 1 by k. So that's what we do, and we finally print the answer. Okay. So any doubts, please ask.
Or could you please explain the seal value? How it's going to how it's happening?
Okay. So basically, the question is that if I ask you that, okay, I give you some integer n, and I tell you that try removing k every time from this number n. Okay, so try removing k every time from this number n. So I remove a k, and now I get a new number n minus k. Then I again remove a k, and I get a new number n minus 2k, and so on, right? And I ask you that how many times can you do this operation so that finally the value of n becomes less than equal to 0? So this is my question. Now, if you think about it, first of all, let's try with small examples. So if you look, suppose the value of n is 10 and suppose the value of k is 4. Then what do? First of all, 10, we reduce it by 4, so it converts to 6. Then we again reduce it by 4, then it converts to 2. And then we again reduce it by 4, and it converts to something which is less than equal to 0, so we don't care. So how many operations which we actually did? We did 3 operations, right? Note that 3 is nothing but the seal value of 10 by 4. So this was our idea. Think like we can take one more example. Suppose I take n as 17 and k as 10. Okay, So what basically happens? You have this 17, you reduce it by a 10 and you get a 7. You again reduce it by a 10 and you get something less than equal to 0. Okay, so how many operations you actually made? You made 2 operations, which is nothing but the seal value of 17 by 10. So my basic idea is that, okay, so what are we actually doing? We are doing, suppose we have this number n. We are, after doing one operation, the value I get, the new value which I get is n minus k. After doing 2 operations, the new value which I get is n minus 2k. Okay, so suppose I do x operations. So if I do x operations, what is the new value I get? The new value I get is n minus k into x, right? And I want this value of x, the smallest value of x, such that n minus kx is less than equal to 0, right? Because we will stop when this value becomes less than equal to 0. So n minus kx is less than equal to 0. So you can manipulate it to write that x is basically greater than equal to n by k. Now, what is the since we need to minimize the number of operations, what is the smallest integer which satisfies this condition? This condition, the smallest integer which satisfies this condition is nothing but x is equal to seal of n by k. Okay, that is the reason we are using seal in our code. Now, this is one important property of number theory, which I will not prove, is that seal value of a by b is nothing but the floor value of a plus b minus 1 by b. You can check it with numbers, and it comes pretty handy when you are trying to print the value of a by b. You can simply convert it and write in this floor form, and then you can write this using a simple division operator in C++, right? You can have examples like, what is the value of seal value of 10 by 3? That is nothing but 4, and which is equal to, the floor of 10 plus 3 minus 1 by 3, right? This is nothing but the floor of 12 by 3, which is again 4. So this inequality holds for all a and b. So I finally use this identity in my code. Okay, so is it clear now? Okay, thanks. Then let us move to the problem B of the contest. So this was problem B. So the question says that you are given an integer array A of size n. Initially, all elements of the array are colored red. You have to choose exactly k elements of the array and paint them blue. Then, while there is at least one red element, you have to select any red element with a blue neighbor and make it blue. The cost of painting the array is defined as the sum of the first k chosen elements and the last painted element. And the question asks that your task is to calculate the maximum possible cost of painting for the given array. Okay, so let me explain the problem statement once. So the question says that as a part of the input, we will be given an array of n integers. So we will be given an array of n integers, right? A1, A2, and it goes on till an. And we will also be given an integer k. Okay. So now what do we need to do? The question says that you choose k integers randomly from this array. Okay. So I choose some k integers, I don't know. So let me redraw this. So I have a long array here. And it goes on. And we need to choose k integers from this array. Okay. Now, so we choose some k integers from this array. Now the question says that you color them blue. So initially all integers were red. So initially all of them were colored red. So I'm not showing the color red for simplicity, but suppose all integers initially are color red, and then you come here and color these k integers which you choose to blue. Okay, fine. So these k integers you choose to blue. Now the question says that after you have chosen these k integers to blue, what you can do is, for all other integers, if you see that it is a neighbor of some red integer, you can make it blue as well. So I can look at this integer a2 and I can convert it to blue. Similarly, all these integers which are neighbor of red integers, you can convert them to blue. So let me show it using an example. So let us try to take an example from the custom test only. So it says 42313. So let us take this array. So the array is 4. Okay, so let me use the color red as they have said in the question. So initially all the integers are red. Okay, and the value of k is given as 2. So the value of k is given as 2. Fine. Now what can you do? You can choose any two integers and convert them to blue. Okay, so suppose I choose this 2 and this 1 and I convert them to blue. So these two integers become blue and rest all of them remain red. Okay, fine. Now, now any integer which has a blue neighbor that you can convert to blue. So consider this integer 3. This has a blue neighbor, right? These are all its blue neighbors. So you can convert this 3 into blue as well. So what can I do? I can convert this 3 into blue as well. Fine. So now this 3 also becomes blue. And it continues. So now suppose I choose this 3 and convert it to blue. And then later I choose this 4 and convert it to blue. So finally, in my array, what happens? Everything becomes blue. Okay. Now the question defines a score. So what is the score of this set of operations? The score of this set of operations is basically take the k integers which you have initially chosen as blue, add them up. So I add 2 and 1 because those are the integers which I initially chose as blue. And then finally add the last element which got converted to blue. So in our example, 4 was the last integer which got converted into blue. So I add a 4 here. So that is 7. And this is the score for my set of operations. The question asks to maximize this score. So we need to maximize this score. Okay. That means we need to somehow smartly choose k integers out of these n integers. So that, and we have to then smartly also define which integers I make blue first, which integers I keep red and make blue in the last. So that at the end, the entire score is maximum. What is score? The score is the sum of all the first k integers which we initially chose blue and the last integer which became blue after this entire set of operations. So that is our score, and our objective is to maximize the score. Okay. So is the question clear? Okay, great. So if the question is clear, let us try to understand the solution. Okay. So this is the first case which we are discussing. Suppose the value of k is equal to 1. Okay, so this is the easy case. So suppose the value of k is equal to 1. Okay, so that means I have some array of integers a1, a2, a3, and it goes on till an, right? Now, since the value of k is 1, what will I do? I will choose exactly one integer from the array that will get converted to blue. So that I will make blue. Then rest, all integers I will keep on making blue. I will get one integer at the end, which will become blue. I will add it up, and that will be my final answer. Okay. So since the value of k is 1, the final answer or the score will be basically the sum of any two integers, right? Because I think it's clear that when the value of k is 2, so when the value of k was 2, how many integers we added in the score? We added 3 integers, right? So that means in the score will be nothing but the summation of k plus 1 integers. So let me write this down, and this is a general statement. The score is nothing but sum of k plus 1 integers, right? The k integers which we initially choose and one integer which finally remains and becomes blue at the end of the operations. Okay, fine. So how do we solve the problem for k equal to 1? So suppose I have this array. Okay. So I have this array and the value of k is given to be 1. And suppose the first integer which I choose to make blue is this integer ai. So this ai gets converted to blue, rest all integers remain red. So what happens next? How can which integer? So how to do an optimal set of operations so that the final score is maximized? Remember that since this integer is blue, there is the only way I can make other integers from red to blue is by converting them from red to blue in this fashion, right? Because this is blue, only its neighbors can become blue. And similarly, these numbers can become blue in this fashion and it propagates in these directions. So that means the last integer which becomes blue is either a1 or an, right? So the last integer which becomes blue is either a1 or an. It has to be one of them. So that means my maximum score, it should be nothing but the maximum of ai plus a1 or the maximum of ai plus an, isn't it? So it should be the max of these two. It should be the max of these two. Why? Because whatever AI you pick, so if the value of k is 1, whatever AI you pick, the last integer which becomes blue is either the first element or is the last element. Because if you make this integer blue, all the integers become blue in this direction. So if AI is blue, the next integer which becomes blue in the left must be AI minus 1. So these things propagate in this direction from AI. So that means the last integer which becomes blue is either a1 or is an. So that means either a1 or an has to be included in my score, right? So that means the maximum score which can be is which we can attain when k equal to 1 is the maximum of ai plus a1 or the maximum of ai plus an for all I. Okay. So is the k equal to 1 case clear? So is the k equal to 1 case clear? Okay, great. So if k equal to 1 case is clear, now let's try to think about the general case. So now the value of k is greater than equal to 2. Okay. And I know, what I know is that score is nothing but sum of some k plus 1 integers of the array. Sum of k plus 1 integers of the array. Okay, that's fine. Now, when I know that the score is nothing but the sum of k plus 1 integers of the array, should I not try to make the score equal to the sum of the k plus 1 largest integers of the array? So what do I mean? I mean that suppose I have some large array given, okay? So suppose I have this, just a second. So suppose I have this large array given, okay? And suppose I mark the k plus 1 largest integers of this array. So suppose these are the k plus 1 largest guys, which are present in the array, okay? So these are k plus 1 largest integers which are present in the array. Can I smartly choose my set of operations in such a way that my score exactly becomes equal to the sum of these elements? Because I know that the score is nothing but the sum of k plus 1 integers of the array, my score can never exceed the sum of the largest k plus 1 guys of the array, right? So if these are the k plus 1 largest guys, the best possible score I can get is the sum of them. Okay. But can I smartly design a set of operations such that I actually achieve this upper bound? Can I do that? So the simple idea to achieve this lower upper bound is basically you take this integer. So initially you need to choose k integers, right? So let me take this first one. Let me leave this one and let me take all these other guys. Okay. So I leave the second one. I take the first one. I leave the second one and I take all the other guys. Okay. So these k people I have already chosen. So these k people are already chosen. Their values will be added to the score. Okay. Now what do I do? I need to now I need to make the other elements blue, right? So I first make this entire thing blue one by one. Then I make this entire thing blue. Okay. Then I smartly make all these things blue. Then in this region, first of all, I make this entire region blue and I stop at this index. Then I make this entire region blue and I stop at this index and I finally choose this index. I choose this index to be the last integer to make it blue so that I add it up to the score basically. So in this way, what can I do? I can make my score equal to the sum of the largest k plus 1 values. Let me show it using an example. So suppose the value of k is suppose the value of k is 2. Okay. And suppose the array looks something like this: 7, 3, 4, 10, 12, 2, and 8. Okay. So suppose my array looks like this and the value of k is equal to 2. So what are the largest values? What are the largest values in what are the since k equal to 2, I need to choose k plus 1, that is 3 integers, right? So what are the largest 3 integers in the array? Those are 10, 12, and 8, right? So my idea is simple. You first convert 10 to blue and 8 to blue. Okay. So initially 10 and 8 get converted to blue. So in my score, 10 plus 8 gets added. Okay. So 10 plus 8 gets added to my score. Now what do? I make all other integers except 12 blue first. So since this is blue, I can make 4 blue. 4 is a neighbor to one of the blue integer. Then I can make 3 blue. Then I make 7 blue. Then I come and make this 2 blue. And I finally choose this 12 at the end. So what is the benefit of choosing this 12 at the end? I can get this 12 as my answer. And this finally gives me the largest possible score, which is 30. Because my score can never exceed the sum of 10, 12, and 8, right? The score is nothing but the sum of k plus 1 integers, and I'm choosing the largest k plus 1 integers to compute my score, so it has to be the maximum. Okay, so is the logic clear? So is the logic clear? Like if the value of k is equal to 1, then we handle it separately. And if the value of k is greater than equal to 2, okay, so Aman tells me to take an example. So let us try using that example. So for example, Aman gives this array 2, 1, 4, 3, 10, 12, and 13. So we get this example 2, 1, 4, 3, 10, 12, and 13. And the value of k is given to be equal to 4. Okay, so the value of k is given equal to 4. So since the value of k is given equal to 4, that means we have to pick 5 maximum elements as our score, right? So what is the 5 maximum elements of this array? Those are 10, 12, 13, 2, and 4. Isn't it? So my idea is simple. I will try to make my score equal to the sum of these 5 values. How will I do that? I initially pick this 2, this 10, this 12, and this 13 as a part of my as the 4 integers which I need to choose. Okay. So when I do that, what does my score becomes? My score becomes the sum of 4 integers up to this moment, 2 plus 10 plus 12 plus 13. Okay. Now, what will I do? I will convert this 3 to blue, and then I will convert this 1 to blue. I can do that. So I basically delay this, making this 4 blue till the end. And I finally add up this 4 to the score because this is the last element which gets picked as blue. So I add up this 4 to my score, and this becomes my final score. So what is this? 2 plus 10, 12, 12, 12, 24, 24 and a 17, which is 41. Okay. So this is the basic idea. I smartly choose the operations in such a way so that the final score becomes the score of the largest k plus 1 integers of the array. 3 should be added instead of 2. Okay, okay, I made a small mistake. Instead of 2, we should add a 3. Yeah, definitely. Sorry for the mistake, but the idea remains the same. Okay, so instead of 2, we try to add a 3. Okay, let me rewrite this. Okay, so since the value of k is 4, we will do something like this. We will first choose k, the value of k as 1, 10, 12, and 13. Just a second. Let me rewrite the example once again. And it says, and Aman says that the value of k is 3. Okay, Ankita, let me summarize the idea again. So my idea is, so let me start with the example. 2, 1, 4, 3, 10, 12, and 13. Okay, 10, 12, and 13. And the value of k which is given to us is 3. Okay, so now, since the value of k is through 3, we need to pick the k plus, we need to pick 4 largest elements of the array, right? I know that my score will be sum of 4 integers from this array. So in order to maximize the score, my objective should be trying to make score the sum of the largest 4 integers of the array. So what are the largest 4 integers of this array? It is this 10, this 12, this 13, and this 4. Okay, so these are the largest 4 integers of the array. So my idea should be trying to make operations in such a way that my score matches the sum of these 4 elements. How can I do that? I first pick this 4. I leave this 10. So I leave the second largest element, and then I take the other 2. When I do that, I ensure that when I'm trying to maintain this score variable, I at least ensure that 3 of these integers, 4, 12, and 13, get added to my score. Okay. Now, I need to smartly do the other operations so that I include 10 in my score. How can I do that? First of all, since this 4 has become blue, I try to make all other integers blue except this 10. So since this 4 is blue, I can make this 3 blue because 3 is a neighbor of a blue integer. Similarly, I can make this 1 blue because 1 is a neighbor of this blue integer. Then I can make this 2 blue because 2 is a neighbor of this blue integer 1. So finally, I make this 10 blue. So 10 becomes the last integer which becomes blue. So that means 10 gets added to my score. So note how I made other integers blue and delayed delayed the coloring of this integer 10 to blue so that I can actually add 10 to my score and my score becomes the largest possible. Okay, so here the score becomes 39, and probably if I have not done any mistakes, this should be correct. Okay, so is the idea clear? Yeah, exactly, Aman. The sum of the largest k plus 1 integers would be my answer. Yeah, Priyansh, for k equal to 1, this case does not hold. Like the k equal to 1 case, we need to handle separately. The problem is when k equal to 1, at least one of the first or the last integer has to be chosen in my score. I have no other choice. So that is the reason in k equal to 1, just choosing the largest k plus 1 integers does not work, and it will give a wrong answer. Like probably you can see here, like if you see here, if I choose the value of k equal to 1 in this test case, you may say that, okay, 12, okay, not in this test case. Let me show you a counter example. So suppose I have a test case like this, 5, 10, 12, and a 6. Okay, and suppose the value of k is given as 1. Now you may argue that, okay, if I do it in the similar fashion, since the value of k is 1, I will take my score as the largest sum of largest two integers. So that is 10 plus 12, which is 22. But note that when k equal to 1, this sum of 22 is not achievable. Why? Because what will you do? You will try to first convert this 10 to blue, right? But when you convert this 10 to blue, you cannot delay converting this 12 to blue till the end. Because if this 10 is blue, you have to first make 5 blue. But after you make 5 blue, you are forced to make 12 blue. So that means 6 becomes blue at the end. So you actually cannot take 10 and 12 simultaneously in your score. If you take a 10, you are forced to pick this 6 in your answer. So when the value of k is 1, you are forced to pick either the first element or the last element in your score. So that is the reason when the value of k is 1, you take maximum of ai plus a1 or ai plus an into your score. Otherwise, you take the sum of the largest k plus 1 integers. Let me show you the code once. It will be a bit more clear and then we can come up with doubts. So look what I have done. I have taken n and k as input. Then I take the vector v as input. Now I break it up into cases. If the value of k is 1, I take the maximum of vi plus vn minus 1. So that is picking the last element. And then taking the maximum of v0 plus vi. So that is taking the first element. So when the value of k is 1, I am forced to pick either the last element or the first element in my score, and I finally print that in my answer. Okay. Otherwise, if the value of k is not 1, it is larger than 1, then I simply sort the vector v, and then I take the sum of the last k plus 1 integers, which are basically the largest k plus 1 values in the array, and I finally print them, the sum of them, as the answer.
रिकॉर्डिंग देख लूंगा रिकॉर्डिंग देख रहा हूँ फिर लिख लूंगा मैं तो ये सोच रहा हूँ
Okay, so is the idea clear? Any doubts?
Could you explain the code once again? The idea is clear, but I'm confused with the code.
Yeah, okay. So let me explain the code once again. So the question is, so the code is simple. That what did we do? First of all, we take n and k as input. Then we take the vector as input. Then what if the value of k is 1? So this is the first if condition which hits when the value of k is 1. When the value of k is 1, then what do? You take the maximum of vi plus v0 or vi plus vn minus 1. So what does this mean? This means that you can choose some integer vi and then you are forced to choose the last integer. Okay. So this for loop basically computes that part. Otherwise, you choose some integer vi, but then you are forced to choose the first integer. You take the maximum of them and then compute the answer. Right. So what does that mean? That means that when the value of k is 1, you can pick one integer of your choice. That is your wish. But the other integer which you pick has to be either the first element or the last element of the array. So that is what we consider using this code. Apart from that, if the value of k is greater than 1, then what do? Then I simply sort the vector. So when I sort the vector, the largest integers come in the end, right? So I sort the vector and then I just add up the last k plus 1 integers of the vector. Okay, and I finally print them in the answer. So I sort the vector, I run this loop for k plus 1 times where I just basically add the back or basically the last integer of the vector. And then I keep on popping up. So that's basically adding up the largest k plus 1 integers of the array and finally printing them as the answer. Okay, so is it clear?
Yeah, now it's clear, sir. Now it's clear.
Okay, so I hope it's clear. Any more doubts? Okay, so if that is clear, let us move with the problem C of the contest. Okay, so this was question C. The question's name is two colors. So it says that Monocarp has installed a new fence at his summer house. The fence consists of n planks of the same size arranged in a row. And Monocarp decided that he would plant his fence according to the following rules. Okay, so what are the rules? Each plank of the fence will be painted in exactly one color. The number of different colors that the planks will be painted in is exactly 2. And the planks of the fence that are painted in the same color must form a continuous sequence. Meaning that for all pairs of planks painted in the same color, there will be no planks painted in a different color between them. Okay. Now it also says that monocarp has m different paints, and the paint of the ith color is sufficient to paint no more than ai planks of the fence. And monocarp will not buy any additional paints. Your task is to determine the number of different ways to paint the fence that satisfies all of monocarp's described wishes. Two ways to paint are considered different if there exists a plank that is painted in different colors in these two ways. Okay, so let me try to explain the problem statement. So this is problem C. So the question says, first the question gives us two integers as input. Okay, so as a part of the input, we get n. So first of all, we get n. What does that mean? So n means that we have some n planks. Okay. So we have n planks numbered from 1 till n. Okay. Numbered from 1 till n. Okay. Apart from this, we are also given an integer m, which basically denotes the number of paints. So it basically denotes the number of paints. Okay. And we are given an array. So we are given an array of size m. So we have these integers a1 till am. Okay. And what does ai indicate? Basically, AI says maximum number of planks you can color, maximum number of planks you can color using, you can color I. So basically, how many planks can you color with this ith color, with this ith paint? So that is basically given using this integer ai. Okay. So now you are said to finally print the number of ways in which you can paint the n planks. Okay. So we are given some paints, we are given some m paints, and every paint has a capacity. Like with the first paint, you can just paint at most a1 planks. With the second paint, you can paint at most a2 planks. Okay. So now the question asks, in how many different ways can you paint all the n planks such that it satisfies some conditions? Okay. So what conditions it should satisfy? The first condition is exactly two colors should be used. So exactly two colors should be used. We cannot use less than two colors. We cannot use more than two colors. Okay. So that is the first condition. The second condition is that the colors which are used must form a continuous sequence. What does that mean? That means that it should form sequences like this, that you first paint the planks with some color 1, and then you paint the other planks with color 2. Okay. So it should not happen that you first paint something with color 1, then you paint something with color 2, and then you again come up with color 1. Like this is an invalid case. So the colors which you basically use to color the planks, they should form continuous sequences. They should not be broken like this. Okay. So this is the second condition. And these are the two conditions. Let me reread the problem statement once. Okay, yeah. So these are the two conditions which should be satisfied. There is one more condition which is quite trivial, that if there is some single plank, that should be colored using the single color. You cannot use multiple colors to color a single plank, and that is all right. So these are the conditions which should be satisfied, and then we need to print. We need to print what is the total number of ways in which we can color the planks using those M paints which are given to us. Okay, so is the problem statement clear? Any doubt with the question? Okay, great. So if the question is clear, let us try to discuss the solution. Now think about this. Think about this. Suppose we need to use two colors to print all the n planks, right? So suppose I said that, okay, I will use colors I and J. Okay. So I will use the colors I and J to paint all the planks. Fine. Now these are my planks, right? All these are my planks numbered from 1 to n. So these are planks numbered from 1 to n. Fine. Now, since it has been said that the colors which we are using must form a continuous sequence, that means what should happen? Like I will initially start painting some planks with color I. Then I will start painting with color J and keep on painting all the remaining planks with color J. Okay. So that means I have two choices. I first need to choose what will be my left color. So I need to choose what will be my left color. Then I need to choose what will be my right color. Right. So suppose if I have many colors available, like the value of m is very large, I need to choose what will be my left color. I need to choose what will be my right color. And then I need to decide in how many ways can I color all the planks using these given two colors. Okay, fine. So suppose I have fixed. So suppose I have already decided that, okay, I will use I as my left color. So I will use I as my left color. And I will use J as my right color. Okay, so suppose I have already decided. Then in how many ways can I color all the given planks? Given I use I as my left color and I use J as my right color. So here some conditions come. So this is the first thing. We need to ensure that the value of Ci plus Cj should be greater than equal to n, right? Why so? Because if the value of Ci plus Cj is less than n, that means you cannot use the colors I and J to completely color all the planks. The colors are basically the amount of colors which we have to is basically not sufficient. So some plank will remain empty, some plank will remain uncolored. So that is not allowed, right? So that means if the value of Ci plus Cj, that means if the value of Ci plus Cj is less than n, then it is not possible to color them. So that means it is not possible to color all the planks using the colors I and J. So that means the number of ways is 0. Okay. So now we assume that the value of Ci plus Cj is greater than equal to n. Now have this observation. If the value of Ci plus Cj is equal to n, then in how many ways can I color the planks? Anyone? Like if the value of Ci plus Cj is exactly equal to n, then in how many ways can we color the planks? One, right? Like if the value of Ci plus Cj is equal to n, and I have decided that I will use I as my left color, J will my right color. So that I have decided. Then there is only one way in which I can color all the planks. What is that way? You basically choose all the Ci planks in the left and then choose all the Cj planks in my right. Okay, that is the only way. So if the value of Ci plus Cj is n, then you have exactly one color. Yeah, exactly. Now, what if Ci plus Cj is n plus 1? Then how many ways do we have? Anyone? Like if I increase the value of Ci plus Cj and I say that the value of Ci plus Cj is n plus 1, then how many ways do we have to color all the given planks? So if the value of Ci plus Cj is n plus 1, then we have two ways to color the given planks, right? What are the two ways? Like since the value of Ci plus Cj is equal to n plus 1, either you can use Ci minus 1 number of planks initially with color I and Cj for the remaining ones, or you use Ci with color I and Cj minus 1 for the remaining ones, isn't it? So if the value of Ci plus Cj is n plus 1, there are two ways to color. So that means if you think about the general form, so that means the number of ways to color the number of ways to color is equal to Ci plus Cj minus n plus 1, isn't it? Like, think about this. When the value of Ci plus Cj was n, then this gets cancelled out and the number of ways remain 1. If the value of Ci plus Cj is n plus 1, then that n again gets cancelled out and the value remains 2. So that basically means that the value of when the value of Ci plus Cj is n, we have one option. And when the value of Ci plus Cj increases by 1, the number of options also increases by, the number of ways also increases by 1. So the number of ways to color all the planks with the ith color in my left and the jth color to my right is Ci plus Cj minus n plus 1. Isn't it? So everyone convinced up to this part? So, okay, great. So if it is clear, so that means I know that, okay, if I use ith color as my left color and jth color as my right color, then I can simply, then the number of ways is simply Ci plus Cj minus n plus 1. That means if I would have to write a big O of n square code, suppose big O of n square is allowed, then what type of code I could have written? I could have written something like this, that suppose for I goes from 0 till n minus 1, and for, sorry, I goes from 0 to m minus 1. There are m colors, right? And suppose j goes from I plus 1 to m minus 1, right? And here we check the condition that if Ci plus Cj is greater than equal to n, then I add my answer with Ci plus Cj minus n plus 1. Straightforward, right? So if the value of, if order of n square or m square code was allowed, I could have written a code simply like this. Okay, but the value of m in this problem is quite large, and writing such quadratic code will give us TLE, right? So writing this code, so even if this code would have given correct answer, it will actually lead to TLE. We need to somehow optimize this. So is it clear up to this part? So if it is clear up to this part, then we will start talking about how can we optimize and improve the time complexity. But is the logic clear up to this? Okay, great. So up to this part, if it is clear, then my idea is simple. For every I, I need to find out. So let me sort. So first my idea is, let me sort the C array. Okay, so let me sort the C array. If I sort the C array, now my C array looks something like this, right? From C1 to, and it goes till Cm, right? Okay, fine. So now suppose there is this pointer I. So there is this pointer I which starts from 0, till m minus 1, right? And this basically denotes the color of my left paint. Okay. Now I cannot run a different for loop for the j, right? Because that will lead to quadratic code. But what can I do? I can use something like a sliding approach. Like I can have a pointer here. I can have a pointer at the right side. So I can have some PTR here and I can check. What can I check? I can check that, okay, is Cm plus C1 greater than equal to n? If Cm plus C1 is greater than equal to n, that means I can choose Cm with C1, right? Okay. So if I can do that, let me move my pointer to the left. So let me move my pointer to the left and let me check, okay, is Cm minus 1 plus C1 greater than equal to n? So if that is the case, then that is also a valid pointer. Like there also cases will come. Okay. So now suppose I keep on moving this pointer and I reach some index, say PTR, such that this is the first index where Ci plus C1 plus CPTR is less than n. Okay. That means for all these integers at the right, the value of Ci plus Cj is greater than equal to n. That is given. Right. So if that is given, how can I compute? So that means I need to compute my number of ways for C1 and all these Cjs, right? So how can I compute? So I knew that for I and j, the number of ways is Ci plus Cj minus n plus 1, right? And how can I write it? I can write something like this, that the number of ways for I and j is Ci plus Cj minus n minus 1, right? Minus n plus 1, right? Now for this index C1, now think about this. I have my pointer I here, and I have my pointer PTR here. What does PTR indicate? PTR is that rightmost index such that CPTR plus Ci is less than n. So that means for all these integers to the right of it, the value of Ci plus Cj becomes greater than equal to n. So we need to count the number of ways. How can I count? What I can do is simply something like this. Okay, let me write it a bit differently. Let me write it as Cj plus Cj plus Ci minus n plus 1. Okay, so for this for all these j, I need to compute the number of ways, right? And add them up. But I will not compute the number of ways for every j. Rather, what I will smartly do, when I reduced my pointer from the right side and kept it here, I will maintain a sum variable which denotes the sum of all these values. Okay, so there is a sum variable which denotes the sum of all these values. So when I compute the sum of number of ways, the sum of these cj's is basically stored in my sum variable. Okay, and then this Ci minus n plus 1, this is the constant part for every j. For every j, we are adding the same thing. So I multiply this Ci minus n plus 1 with the number of j's basically. How many j's do we see? So basically, this is the pointer variable. The total number of integers is m. So basically, we multiply this with m minus pointer. This can be a plus or minus 1 off, depending on we are using 0-based indexing or 1-based indexing. But this is basically how we compute the sum, right? Instead of finding the number of ways and adding them up for every individual pair I and j, what do? I fix I. I then maintain my pointer variable and look at all these j's. I store their sum in a sum variable, and I compute the sum of all the number of ways together using a simple computation. Okay. Now, why can I do this? I can do this simply because of the fact that when this pointer I basically shifts to the right, this pointer keeps on shifting to the left. So every time as the value of Ci increases, the value of Cj decreases, right? The value of the smallest, like the largest Cj such that Ci plus Cj is less than n, that decreases. So as my pointer I moves from left to right and makes a single scan of the array, this pointer variable also makes a single scan of the array from right to left. And that is the reason why is it possible. Okay, so any doubts? Yeah, Priyansh says it's m minus ptr plus 1. Okay, so let me correct this. It should be m minus ptr plus 1. Why so? Because ptr is the largest index such that ci plus cj is less than n. So the number of indices which lie to the right of it should be m minus ptr plus 1. Like you can quickly verify it from the fact that when ptr is m minus 1, then it should be 0, right? Okay, I think then it should be m minus ptr minus 1, right? Just a second. Shouldn't it be m minus ptr minus 1? Because when the value of ptr is m minus 1, then this count variable should be 0, right? Because then if the value of ptr is m minus 1, so then that means the pointer lies strictly to the right of the array. So there is nothing to the right of it. So the count is 0. So we should multiply it with m minus ptr minus 1, right? Okay, let me quickly run an example. So let us try to take an example. Let me take this example 5, 9, and 8 for the third test case. Okay, so it says the value of n is equal to 5. The value of n is equal to 5, and the array is 5, 9, and 8. Okay, so this is my array. So let's start. So this is the first iteration. So the first iteration, the value of I is equal to 0. Okay, so this is my array. It stands here 5, 9, and 8. And this is my pointer I, which stands at 0. Okay, and this is my pointer variable PTR, which stands at 2. So now I try to find out that, okay, is my Ci plus Cj greater than equal to n? So this is 5, this is 8. So is 5 plus 8 greater than equal to n? Yeah, definitely. It is great. So the value of n is 5, right? Just a second. Sorry, the value of n is given here as 12. So let me write 12 here. So the value of n given here is 12. So let me write 12 here. And also I did a mistake here. We initially sort the array, right? So we sort the array. Let me sort this, because if you do not sort, then it will create problems later. Okay, so I sort this. So now this is my array 5, 8, and 9. And now I have my I equal to 0 pointer here and my pointer PTR equal to 2 here. Okay, fine. So now let us try to compute. So initially we check, is 5 plus 9 greater than equal to my value of n? So yes, 5 plus 9 is greater than equal to n. So I shift my pointer one side to the left. Okay. So now what do I do? So basically this pointer I remains there, but now my PTR shifts 1 point to the left. So here is where my PTR points. Now again I check, okay, is the value of Ci plus CPTR is again greater, so it shifts to the left. Okay, so it shifts to the left and it becomes 5, 8, and 9 with the pointer shifting here. The pointer points now here. So now is the value of Ci plus Cj greater than equal to n? So it is 5 plus 5, 10, which is less than equal to n. So that means we stop. Okay, now what do I compute? So now I just basically need to, I know that this is my pointer. That means when I stands here, when I is my left color, these are the possible options which I have as my right color. Okay, so what do I update my answer with? I say that answer plus equal to, as we wrote, okay, so there is one sum variable we maintain, right? So let me maintain here. So when this pointer moved here, I increased my sum variable with 9. So my sum became 9. Okay, so this value increased my sum. When I again moved the pointer again to 1 point to the left, I increased 8 to the sum. So the sum became 9 plus 8, which is 17. Okay. So now when I basically update my answer, I update it with sum plus m minus PTR minus 1 into Ci minus n plus 1. Right. So what does that get updated with? We have a 17. The m minus PTR minus 1, you can check, that's a 2 multiplied with a Ci minus n plus 1. So that is 5 minus 12 plus 1. Just a second. Did we do some mistake? I don't think so. So it's right, I guess. So it is 17 plus 2 times. So this is 6 minus 12, that is minus 6. So that is 17 minus 12, that is a 5. Okay, so after the first iteration, the value of answer becomes 5. 5 plus 1, 6 minus 12 minus 6. Yeah. So after the first iteration, the value becomes 5. Okay, so guys, please point out if I make some mistake in between, because otherwise it may create problems. So the first iteration is done. So let's start with the second iteration. So in the second iteration, this is where my I stands, right? And my pointer stands here. Okay, fine. So my pointer stands here. So what do I do? I basically again check my value of n is 12. Okay, I again check, okay, is the value of 8 plus 5, that is Ci plus Cptr, greater than equal to 12? So 8 plus 5 is 13, that is greater than equal to 12. So that means I again shift my pointer to one side to the left. Okay, so my pointer gets shifted to one side to the left. So my pointer moves out of the array. My sum variable, it was initially 17. It again gets increased by 5, so it becomes 22 now. Okay, so the sum becomes 22 now. Okay, so now this pointer cannot be moved to the left. So I update my answer. So how do I update my answer? Again the same thing. So answer is sum, which is 22, plus the count is 3, which is, this 3 is nothing but m minus ptr minus 1 multiplied by ci minus n plus 1. What is ci minus n plus 1? That is 8 minus 12 plus 1. That is 9 minus 12, that's minus 3. So this is 22 minus 9, which is a 13. Okay. So which is a 13. And initially in the first iteration, we had answer 5. So we added 13 with 5. So after this iteration, the value of answer becomes 18. Okay. So now let's move on to the last iteration. So this is the last iteration. So this is where my I stands now. My pointer remains here. It does not move. So since it does not move, I simply update my answer. There is no point moving the pointer once again. So how do I increase my answer? I say my answer is plus equal to sum. Sum remains 22 plus the count, which remains 3, into ci minus n plus 1, so which is 9 minus 12 plus 1. Okay, so which is 22 plus 3 times. So 9 plus 1 is 10, 10 minus 12 is minus 2. So that is 22 minus 6, which is 16. Okay, so initially I have an 18 from previous iterations, and then I have a 16 from this iteration. So after all the iterations, the final value becomes answer equals 34. Okay, and this computes all the possible ways to compute the answer. But then if you look at the answer given here, it is, for this test case, the answer is given 22. So we missed something, like we were wrong something. Can anyone point out? Like why it's coming 34 from the dry run, but the answer given is 22? Exactly. There is one thing which we missed, and that was, like think about what happens when the pointer has come here. So this is my CI, right? So suppose CI is 9. For this I, we are trying to compute the number of ways for all values of j which are to right to the pointer. That means for this 9, we are trying to compute the number of ways for j equal to 5, for j equal to 8, and for j equal to 9. So that means we are unnecessarily adding up the cases where I and j are the same. We cannot make I and j are the same, right? I and j have to be different in when we compute the valid number of ways. So that means you have this 34, but what is the new array? The new array is 5, 8, and 9, right? And the value of n is 12. So now there are some ways, there are some things which you have computed multiple times. Which one? So like take this 5. So are there cases where you took both I and j equal to 5? That cannot be the case, because ci plus cj is 5 plus 5, which is 10. 10 is less than equal to 12. So we have not taken cases where both I and j are 5. So that is all right. But look for 8. When it was 8, when I was 8, we have considered a case when j was also 8. So that was unnecessary overcounting. So we need to reduce that part from 34. So what was the overcounting here we made? So the overcounting is simple. It was ci plus cj, that was 8 plus 8 minus n minus 12 plus 1, right? When I is also 8, j is also 8, this is the number of cases which we have overcounted. So what is the number of cases? It becomes 16 minus 12, that is 4, plus 1, 5. Okay. Similarly for 9. For 9, what is the number of cases we have overcounted? 9 plus 9 minus 12 plus 1, right? Ci plus Cj minus n plus 1. So that is 9 plus 9 minus 12 plus 1. If you compute it, it is 7. So that means 5 and 7 are the extra cases which we have computed, which basically considers those cases where I and j are the same. So we need to remove that from 34. So we remove 34 from 34, 5 and 7, and the final answer which we get is 22. Okay. So is the logic clear? The problem where we were overcounting is that we were considering those cases where I and j are basically the same. So that was the problem. So let me show you the code once, and then we can come up with later doubts. So look, what do I do? So first of all, I take n and m as input. I take the colors as input. And this is one thing which I do. Basically, I say that, okay, the color, like what is the maximum number of colors you can use? Like what is the maximum value of Ci? The maximum value of Ci can never exceed n minus 1, right? Because you need at least 2 colors. You require exactly 2 colors to color all the n planks. That means using one color, you can never color more than n planks. So that is the reason I say that, okay, well, basically like say that the value of Ci will never exceed n minus 1. So I overwrite Ci with minimum of Ci comma n minus 1. Okay, fine. Rest is simple. I sort the C array. I maintain a pointer at ptr at m minus 1. I maintain the sum variable and I maintain the answer variable. Okay. And then this is the while loop. While ptr is greater than equal to 0 and this c ptr plus ci is greater than equal to n, I decrease the value of pointer and I store their sum, the value of c pointer in the sum. I add it up. Okay. And then I basically compute the number of ways. What is the number of ways? That is basically the sum plus m minus ptr minus 1. This denotes the count into ci minus n plus 1. The expression we discussed earlier. Okay. Apart from that, this basically reduces the overcounting. If I see that 2 into ci is greater than equal to n, that means we have counted those cases. We have overcounted those cases where I've taken I and j to be the same thing. And in that case, I just do answer minus equal to 2ci minus n plus 1 to reduce the overcounting. And I finally print the value of answer. Okay. So is that fine? Yeah, Ankita, you can dry run on a few other test cases and let me know if you have doubts. So, okay, Abhijit, let me explain the first loop. So, are you talking about this loop, like the one which says Ci is min of Ci comma n minus 1? Okay, so this problem appears like we tried to find out an expression that to color I and j, the number of ways you take is Ci plus Cj minus n plus 1, right? But this expression was slightly wrong. Like think about the case when Ci is also equal to n and Cj is also equal to n. So what is the value of this expression? Ci plus Cj minus n plus 1. It is n plus 1, right? So that means when the value of Ci and Cj both are equal to n, the number of ways is n plus 1. But that is wrong, right? You can never have more than n minus 1 ways to color the planks. If you have some n planks and you have to color them with at least 2 colors, with I in the left and j in the right, then the number of maximum colorings you can have is n minus 1. You can never have n plus 1 colorings. So why did this problem appear? This problem appeared because Ci and Cj, like this value n is invalid for Ci. Think about this. That you can never have value of Ci greater than n minus 1. Why? Because using one color I, what is the maximum number of planks you can color? N minus 1, right? Because if I have n planks, so if I have n planks, say P1 to Pn, okay, and I need to use 2 colors. I need to use at least 2 colors to paint all these n planks. That means the maximum value of Ci I can afford is n minus 1. So that is the reason whenever I see a n, it is nice to override them and write n minus 1 here. If you do that, then this expression will be correct, because now you will get the correct value of Ci plus Cj minus n plus 1, which will be basically n minus 1. Okay, so the first for loop does this simple thing. Whenever it sees an n, it overrides it with n minus 1. So basically it sets Ci as minimum of Ci comma n minus 1, so that the value of Ci never exceeds n minus 1. Okay. Okay, is it clear? Okay, great. So if that is the case, let's start with the problem D, or the last contest of today, last problem, which we will discuss in today's PCD. So this was question number D. The question says that you are given two non-negative integers x and y. Okay, so two non-negative integers x and y are given to me. Note that the value of x and y is huge, like they can be up to 10 to the power 17. Okay, fine. So now it says that you can perform the following operation any number of times, possibly 0. Choose a positive integer k and divide either x or y by 2 to the power k, rounding down. And the cost of this operation is 2 to the power k. Okay. However, there is an additional constraint. You cannot select the same value of k more than once. And our task is to calculate the minimum possible cost in order to make x equal to y. Okay. So let me explain the problem statement once. So the question says that in input, it will give us two integers x and y, which can be very large, like they can be up to 10 to the power 17. Okay, fine. Now the question says that in one operation, what you can do, you can take some integer x or y. Suppose I take x, and you can divide x with 2 to the power k. So pick some k and divide x with 2 to the power k. So you set x equal to x by 2 to the power k, basically, where you do this with lower bound. So that is basically you take the floor of it. Okay, fine. So now you can never take, and the cost of this operation is 2 to the power k, that is given. Okay, so the cost of such an operation is 2 to the power k, where you divide the x by 2 to the power k. Fine. Now it has been said that you can choose a k only once. So suppose you divide x with 2 to the power 5, then you cannot use 2 to the power 5 again, neither with x nor with y. Okay. And the cost of such an operation would be dividing with by 2 to the power 5 would be 2 to the power 5 itself. Now what we need to find out, we need to find minimum cost. We need to find minimum cost to make x equal to y. So we need to find minimum cost to make x equal to y. So that is the question which I have been asked. Okay, so is the problem statement clear? Any doubt with the question itself? Okay, great. So if the question is clear, let me try to think it like this. First of all, if you guys are comfortable with binary representation of integers, you must know that suppose I have some integer which in binary form looks like this. Okay. So suppose it looks like this. When I divide this number by 2 to the power k and take the, just a second. So when I divide this number by 2 to the power k and take the floor, that is nothing but taking the last k bits and erasing them, which is basically shifting this value by k bits. Right? So suppose I have some integer 10100. So what does this integer denote? So this is 1, 2, 4, 8, and 16. So this represents 20. And suppose I divide it with 8. So 8 is nothing but 2 cube. So that basically means these 3 bits get wiped off. So I finally get 1, 0. 1, 0 in binary represents 2. You can also look that 20 by 8 and the floor of it is nothing but 2. Okay. So when you divide a number by 2 to the power k and take the floor of it, that basically means shifting the number in its binary form to towards the right by k bits. Okay, fine. So now my idea is that I have been given two integers x and y, right? And finally, what is the objective? The objective is that I need to divide x with some powers of 2. I need to divide y with some powers of 2, and I have to finally make them equal, right? So that means I need to shift x with some a. I need to shift y with some b, and I need to finally check is are these two values equal? If these two values are equal, that means we can try shifting x by a and try shifting y by b, find out the cost and take the minimum of all such y, a and b. Okay, so that is the idea. So this gets the inspiration of a DP state. So why not try to think a DP state of this form, like DP A, B, and K? What does this denote? This denotes the minimum cost to shift x by a bits, y by b bits, by using at most 2 to the power k. Okay, so this is my DP state. What does DP A comma B comma K represent? It represents what is the minimum cost if you want to shift x by a bits, y by b bits, and you ensure that okay, I will never take something in my operations which is larger than 2 to the power k. Okay, so this is my DP state. Now tell me, how can we compute this DP state? So we need to compute this DP state. So what can be the base case? So what is the base case? Anyone? Can anyone tell me the base case like of this DP transition? Like is the meaning of the DP state clear? Like what does the DP state DP A comma B comma K represent? Like is that clear? Okay, so let me explain once more. So DP A comma B comma K. So we know that we have to finally shift x and y by some bits, right? So yeah, I have some integer x. I will shift it by some bits a. I have an integer y which I will shift by some bits b. Okay. So my idea is try to think of a DP state where DP A comma B comma K denotes what is the minimum cost to shift x by a bits, to shift y by b bits by using at most 2 to the power k. So that means I will never use. So while computing DP A comma B comma K, so what does that means? I need to compute A comma B, DP A comma B comma K. That means finally I have to do something such that x becomes converted to x by 2 to the power A. Y gets converted to y by 2 to the power B. So basically, and I never use something larger than 2 to the power k in my operations. Okay. So these are the conditions. Like DP A comma B comma K represents that I have to, what is the minimum cost to convert x to x by 2 to the power A, to convert y to y by 2 to the power B, while never using anything more than 2 to the power k in my operations. So whatever k I choose in my operations, that will be less than this value of k basically. Okay. So if you think about the base case, if I think about the base case should be simply dp 0 comma 0 comma k. Like I need to shift x by 0 units and y by 0 units. So what should be the cost for this? It should be 0, right? Because if I need to shift x by 0 units and I need to shift y by 0 units, that basically means doing no operations at all. So whatever be the value of k, dp 0, k is 0. And this is for all k. Okay, so is the base case clear? Okay, so if the base case is clear, let us try to write the transitions. The transition is very simple, like it is very similar to the knapsack problem. In the knapsack problem, we do something very similar, right? We try to write a DP state where we try to find out, like we try to choose pick and not pick, right? So let me write the DP state. So I have this DP A comma B comma K. Okay. So there are two choices which I have. The first choice is not pick. So I know that I can pick this K and use it to shift either X or Y at least at most once, right? So I can either I can do it or I cannot do it. So there are two choices which I have. Either I pick K or I do not pick K. If I do not pick K, then what does it transition to? It is nothing but dp A comma B comma K minus 1, isn't it? So that basically means that we need to shift X by A units, we need to shift Y by B units, but now we have thrown away K, we are not picking K. So now we come to K minus 1, right? So this is the not pick idea. And what do we do? What if we do a pick? So first of all, if you do a pick, so you are picking this K, so that means you have to give the cost of 2 to the power K. That is given. If you pick a K, then you have to give a cost of 2 to the power K. No one can help about it. After that, you can either use it. So what you can do, so it's 2 to the power K plus 2 to the power K plus minimum of, you have two choices, right? You have this K, you can use this to shift either X or Y. If you use it to shift X, so it becomes something like this. And if you use it to shift Y, it becomes something like this. Sorry, this will be K, and this will be K, and this is K minus 1. Isn't it? So try to think about the DP transitions. I am saying that DP A comma B comma K is the minimum cost required to shift X by A, to shift Y by B, using at most 2 to the power K. So there are two ways. Either you choose 2 to the power K or you do not choose 2 to the power K. If you do not choose 2 to the power K, you basically transition to the same things A and B, but with K minus 1 here, right? Basically, you have thrown away your power of choosing 2 to the power K. So that is one thing. Or other, what is the other case? The other case is you choose 2 to the power K. If you choose 2 to the power K, you need to incur this cost of 2 to the power K in your transitions. That you need to do. And then now you have this, since you have used this K, so the amount you need to shift X or Y, so that reduces by K. So if you use it on X, then you do not need to shift X by A anymore. You need to shift X by A minus K now, right? Because this K part is already done by this 2 to the power K. So I can use it on A, X, or I can use it on Y, which gives me two options. And I finally take the minimum of them. So I take the minimum of this and this, and that is basically my value of dp A comma B comma K. Okay, so is the transitions clear? Okay, so is it clear? Any doubt with the transitions? Anyone? Okay, so I would assume it's clear. So if that is the case, then how can I use this dp table to finally compute my answer? So it is simple. I have given two integers x and y, right? These two integers x and y are provided to me. I will simply run a for loop for a in range, say 0 to 60, right? And I will also again run a for loop for b in range, again say 0 to 60. And then I will check that, okay, if is x shifted to a, equal to y shifted to b. If x shifted to a is equal to y shifted to b, then what does that mean? That means that if you shift x by a units and if you shift y by b units, then you are done. Then x and y will become equal. Okay, so we need to find the minimum cost to convert x to a and y to b. So what we can do, we can simply write answer as minimum of answer and so what is the minimum cost required to shift x by a units and y by b units? That is stored in my dp a comma b comma, and what is the maximum value of k you are allowed? Say you are allowed till 60, right? Because something like this, because 10 to the power 17 is at most 2 to the power 60. So this is the transitions. So any doubt with anyone here? Anything here? With any part of the logic, with the DP transitions or the code? Like my idea is simple. I know that if I can compute this DP table, so basically I need to shift x by a units, y by b units, and then if I can somehow compute what is the minimum cost to shift x by a units and y by b units, I'm done. So I do this simple thing while doing my writing my DP transitions. I know that okay, if I need to write DP a comma b comma k, there are just two ways. So either it has to be a not pick, that you do not pick k, or you pick k. If you do not pick k, then the transition is simple. It should be DP a comma b comma k minus 1. That basically says that the amount you need to shift for a and b remains the same. Just the value of k reduces by 1 because you throw away your power of using the k. Similarly, if you use the pick, then you incur the cost for using this k and suitably update your shift amounts for a and b respectively. So let me show you the code. So this is the code. I first of all update, or I basically first of all initialize the entire DP array with infinity. And then this is my base case. I said that for all values of k, dp00k has to be 0, because this basically means that you are not doing any operation at all. You are shifting both x and y with 0. So that is basically the cost would be 0. After this is basically simply my dp transition. So I've written that exact same thing, that dp a comma b comma k. Just a second. So it will be minimum. So ignore this comment. This comment is a bit wrong. But dp a comma b comma k should be minimum of dp ab k minus 1 and these two terms. So that is what I've written. So I've initialized dp ab k with dp ab k minus 1. And then if a is greater than equal to k, I take the minimum with dp a minus k b k minus 1 plus val. Val is nothing but 2 to the power k. And I suitably write the transitions. Okay. Then how do I process each test case? While processing each test case, I just iterate over all possible values of a and b, which basically says the amount of shifts available. And I check that, okay, if the value of x and x shifted to a and y shifted to b is equal, then I can, then dp-ab57 denotes the valid cost of shifting x with a and y by b, because that will make x and y equal. Okay. So now why have I chosen 57? So I have chosen 57 because 2 to the power 57 roughly exceeds 10 to the power 17. So just taking that value would work. Okay, so any doubts at any part of the solution? Okay, Ujjwal, let's try to solve it. But if there are no doubts with problem D, then I will stop the recording. So I hope it's clear for everyone. Okay, so let me stop the recording.